A very good morning, children. Today we are going to see about pressure. So as I told you earlier, the pressure is again related to an force. So you look at the two image where the hand is holding a pencil. So I am going to do the same now. So for example, if I hold a pencil like this, okay? If I hold a pencil like this, so that the one end is lead, another one end is the back side of the pencil. If I hold it and for some time, so what will happen? I feel some pressure on both the finger, right? Let me remove the pencil. Yeah, you can see there is a point on my one finger and there is a little depression on my another finger, right? So there is a more depression on the one finger and there is a less depression on the another finger. Why so? The force applied on both the sides remains the same, but the pressure is more on one side and the pressure is less on another side. Where there is a more pressure, there is a more depression. Where there is a less pressure, where there is a less pressure. Clear? So this is the best example for the pressure. So let me explain you what is a pressure little elaborate. So what is a pressure? The force acting on a unit area of a surface is called as an pressure. The force that is acting on a unit area on the surface is called as an pressure. So the example is here. So I am applying a force between the two finger with the help of the pencil, and the pencil tip is an area. So the force that acting on the surface of an area is called as an pressure. So pressure is equal to an force by area. The pressure is equal to one force by area. What is the formula of pressure? Force by area. The SI unit of pressure is an Pascal. PASCAL. The SI unit of pressure is a Pascal. It is named after the scientist. And it is denoted by the symbol PA. Capital P, small a. So you can write the pressure as in 1 Pascal. And what is the unit of force? 1 Newton. And what is the unit of an area? SI unit, meter square. So 1 meter square. So this is a formula of pressure. The pressure equal to force by area. And its unit is in Pascal. So pressure depends on two factors. On seeing the formula itself, you can say it depends on two factors. It depends on force and it depends on the area. But the force is on the numerator. So wherever the force increases, the pressure will increase. Whereas the area is on the denominator. Wherever the area increases, it is inversely proportional. So the pressure will decrease. When the area decreases, the pressure will increase. When the area increases, the pressure will decrease. So you can look at here. More force applied, more pressure. Area. If you take an area, greater the surface area on which the pressure is applied, lesser the pressure. Whereas the lesser the surface area, more the pressure. Is it clear? So if you know the formula, you can write this on your own. So the pressure equal to force divided by area. The force is a numerator. So if the quantity of the force is increase, the pressure will increase. Whereas the area is in the denominator. When the area is more, the pressure will be less. Is it clear? So these are the two factors on which the pressure depend. Okay. And the pressure example in our daily life. The first one is the school bags have a wider strap. You know very well the school bag have a wider strap because when you carry a load, what will happen if you have a thin strap? First thing is the strap will break easily. The second thing is like the weight you will feel more. The pressure will be more on your shoulder. In order to reduce the pressure only, you will have a wider strap in your school bag. Clear? The next example is a building having a wider foundation. So when they are constructing a building, you know, the apartment or anything, what they will do is they will have the foundation in a larger area. So when the area is more in the foundation, what will happen? The pressure will be less. So you are increasing an area to reduce the pressure. There is another quantity you are going to learn as an thrust. So the force acting perpendicular to the surface is called as an thrust. For example, you imagine this is a surface and the force is on the pencil, and if you press it, the force is actually, the pencil is perpendicular to the finger, right? So this force is called as an thrust. Clear? What do you mean by pressure? The pressure is enforced by area. And what is the unit of pressure? Pascal. And it is denoted by the letter PA. What are the two quantities on which the pressure depends? One is a force, another one is an area. How it depends? When the force is more, pressure will be more. When the force is less, the pressure will be less. What about the area? When the area is more, the pressure will be less. When the area is less, the pressure will be more. And there are two examples. And also there is a one more thing you are learning is a thrust. The force acting perpendicular. The force which is acting perpendicular to the surface is called as an thrust. Clear? We'll move on to the application of an pressure. So before that, let me explain you with another example. Look at this picture. Take 5 wooden box of almost same size. I am taking in 5 wooden box almost same size. Fill them with the scrap iron to make them heavy. So I am putting an iron pieces inside the wooden box so that it will be little heavy. Arrange these box on the wooden table, placing them side by side. I am placing a box one near to the another. Okay, that is side by side. See the impact of push force from this box on the table. So when I leave it for some time, what will happen? I will not notice anything because the table remains normal. The table remains normal. It is not affected by an force. It is not affected by an force, that is the weight of the box upon it. So when you place all the 5 boxes side by side, you are not seeing any changes. Whereas if the same box is kept one above the another, okay, so that time what will happen? The area is very less. Okay, when the area is less, what will happen? The pressure will be more. So the weight of all the 5 boxes will be concentrated on this lesser area, so the pressure will be more. So you can see there is a bend on the wooden table. There is a bend on the wooden table. This is a good example for the pressure. So when you increase the area, the pressure is less. When you decrease the area, the pressure is more. Clear? These are the some of the daily life example. So you know very well, if you take a knife with the sharp edge, the sharp knife if you take with a very thin edge, what will happen? It is easy to cut an vegetable or anything. But if it is have a blunt one, what will happen? You have to apply in more force to cut the item. So when the area of contact is very less, you have seen in the knife the area of contact is very less, so the pressure is more. The pressure is more. So and the large amount of pressure cuts the object easily. Clear? And there is another example. You can see the needle. So the needle with the thread. So the needle edge is very pointed size and the area is very small. So because of the very small area, it produces a larger pressure sufficient so that the needle will enter into the cloth and it can be being stitched. Is it clear? So lesser the area, more is the pressure. These are the application involving high pressure. High pressure in the sense the area will be very less. So the sharp edge is one of the example, and the shoes with the spike. So on the soles of the shoe, what will be there? There is a spike. What will happen? It will give you one more grip when you play on the ground. And then even the ice skating. The ice skating shoe, if you see, it is very thin. The area is very less and the pressure will be more. Clear? So these are the some of the example involved in where the high pressure and the less area. So the next one is application involving in low pressure. So this is like foundation of the building. What will happen? The area is more, the pressure is less. And if you look at a snowshoe, the area is more and the pressure is less. Tire of the tractor, you know very well, it is a very big. So area is more, again the pressure is less. What is the feet of the elephant? The elephant is very big, you know very well, right? And the feet of the elephant is also big so that it can withstand the weight of the elephant. And the area of the feet of the elephant is more, so the pressure is very less. Clear? And this again I told you, a school bag has a wide strap so that the weight of the bag may fall over a large area of the shoulder, thus resulting in the less pressure on the shoulder. Due to the less pressure, you feel comfortable to carry an heavy school bag. Clear? And again, these are the some of the uses of force and pressure. To hang a clock on the wall, what you have to do? You have to beat the nail with the hammer. So the nail will have an pointed area. That means it has a less area, so that the pressure will be more. So the hammer has a broader end and the nail has a smaller area. Hence, when the force is applied, the nail can easily able to hang the clock. We can able to easily hang the clock on the nail. Next one, scissor. That has a sharp cutting edges, and the force acting will be on the small area, and hence you can able to cut using an scissor easily, so that the pressure is more and the force is less. Snowshoe are designed in such a way that our body weight gets spread over a large area, hence reduce the pressure on the snow, and you can feel easy to walk on the snow. The snowshoe will have a larger area, so the pressure will be less, so that it will be easy for you to walk on the snow. The next one is, the ladies in the village keep a cloth folded on the head, and then they keep a lots of pot one above the other. Okay, you know, if you simply carry a pot on your head, you feel the heaviness on your head, so the pressure will be more. Whereas if you fold the cloth and if you roll it in the form of a circle, and if you place it, then again if you place the pot above the cloth, what will happen? The area you are increasing is more and the pressure will be less. So these are the applications of pressure. So this is very important topic. This you are going to learn little more deeper in your higher class. So basically you understand what is a pressure, what is the formula of pressure, and what is its unit, and also like in which factor it depends, and then applications of pressure. And you will be solving few numerical based on the pressure and the force. Clear? So as I told earlier, the force is related to pressure because the pressure is equal to force by area. So thank you children. We'll see you in the next video.